different variations of line plots. See, line plots we have seen with different features included for graph, basic graph. Next comes your scatter chart. Suppose that your values are listed here and there, and you don't want to have an interconnection between those values. You can go for creating scatter plot. Okay, so the only difference that is between the plot, line plot, and the scatter plot is there it is plt dot plot, here it is plt dot scatter. No more changes. So as usual, x, y, y1 is what we have created. So because x and y, I am going to have one graph, x and y1 we are going to have another graph. And the title x label, y label we set, and then we are going to draw two scatter charts. So with xy and x1, y1. For legends you can create of your own. Label is equal to 1 states that the legend for graph 1 is 1 and the legend for graph 2 is 2. Okay. So here color of the first graph we want to be green, second can be red. So here coming to color, you can represent you can write like this, or you can use single character like G, R, W, B for representing the colors. So since the graphs are already labeled, you don't need to specify like this. The legends you don't need to bother, you can just add the legend using plt.legend of. Okay, so let me execute and show you. The legends will be labeled with 1 1. See, you can see there is no interconnection between the dots. Okay, so if you want to make it more clear, you can increase the step from 2 to 20. Again, same here also. If you do like so, then the visibility will be very clear. You won't have any interconnection. See, you can see the dots alone will be there in place instead of interconnecting the dots. Okay, that is the difference between line plot and scatter plot. Look at the legends, whatever labels you have given, that has become the legends. Now you can overwrite those labels also. Suppose if I want A and B to be listed, you can write, and if you execute, you can see the legends got changed. Okay, so that is your scatter chart. Okay, so this is one another scatter chart with grids. Okay, so again everything is the same, and here we have included one more of property to set the size of the figure that you want. Okay, so till now whatever graphs we have generated, the size will be taken as of its own depending on the values that you give. Here we are going to set the figure size. Okay, so plt dot figure is the method name. Have to pass in the parameter in inches. Figure size is equal to 5 comma 5. It is 5 inches by 5 inches. Okay, so other operations are similar in what we have seen. Just we will execute and check. See, it's in 5 cross 5. That's the only difference. Okay, and also one more thing is that the grid lines are being set. You can see till the before graphs we haven't displayed the grid lines. If you want, you can make it available. Yes, this twin axis is the most important concept that's available in Python to visualize the comparison between one data with two different datas. Okay, so the concept is that I'll just execute first and show you how it looks like, then we'll come back. You can see the x value ranges from 0 to 10. On to its left, the y value ranges from 0 to 100. So this graph is between x and y value, right? On to its right, you can see the values from 0 to 1000. See, the y axis and y1 axis values are entirely different. This is twin axis. Okay, so this axis you are going to duplicate to this axis. Duplicate in the sense the x-axis will remain same. Okay, so how to do that? So figure, first we are creating using plt.figure of. We are going to add a subplot first to the figure. The subplot takes 3 parameters. Subplot are nothing but a portion of the plot. So it is like you can have any number of plots, subplots on a single plot in a matrix format. Okay, so matrix format is like We know the rows will be indexed with 0 to n minus 1. The columns will be indexed with 0 to n minus 1, and every location has to be numbered, right? So 1, 2, 3 likewise on the first row, on the corresponding column. Or subplot takes three parameters. One is the number of rows or the corresponding row. If you write 1, it means first row. Okay. Second is the number of columns you have. Third is on which column you have to print this corresponding plot. Okay. So now it is 1, 1, 1, which means one row, one column, and in the same row you are going to do. As of now, you understand till this. We will see in detail in the next graphs. Okay. So then axis 2 is just a duplicate on the right hand side. We are going to create a twin using twin x of. Okay. Twin x in the sense we are going to make a twin for the x-axis. Okay. So I'm going to create a list having values from 0 to 10. So how many number of values I want in between is 100. Okay. List 2 square of numbers, list 3 is cube of numbers. That's all. Okay. So axis 1 dot plot is between x and x squared. Axis 2 plot is between x and x cube. Keep in mind the x value should remain the same. Okay. So if you draw, it will come like this. Okay. And in order to customize your graph, you can change the color by using this color C parameter. That is a color parameter. The marker you can differentiate. See, the marker is like instead of placing a dot, you can place some other symbol. And the line style can also be changed. Okay, I'll just run this program and I'll show you. You can see. So the first plot with the blue color. Okay, if you look at, I have used the marker as this vertical bar. Okay, so it looks like a continuous symbol, but on the top if you visualize, it is just a vertical line rather than continuous line. Okay, on for the red graph within red color, I have given the line style to be hyphen hyphen, so that is come. So you can change the property of the graph, display property, and you can enjoy. Then comes your bar chart. So bar chart we know. Okay, so mostly we'll be using it to represent how many number of people have attended this museum this year, how many number of people have enrolled onto this course this year. Likewise, some sort of continuous or data if we have, that we can represent. Okay, I'll just execute this and show you. Yeah, it's exactly a bar chart. With the bar chart, we can explain the code. See, the left x-axis represents the years and the y-axis represents the visitors to a particular place X. From 2015 till 2019 is what is the data stored in the as a list. Okay, so now create a list index for the list. So why this is created is like, so we want the and 0, 1, 2, the data to be displayed in the midst. That's why it is created. Otherwise, you don't need to bother. Bar width is equal to 0.6. So the entire one space, that is the entire space will be considered as one unit. Within that, we have given 0.6 as the value. Okay, how to draw the bar chart? Plt.bar of what is the x value? It is stored in index, and then the y value it is stored in visitors. Okay, so since we have created a index for the years, we don't need to bother. So the bar width will be 0.6, the color is green. That's all, it will create a value for you. Now that 0.6 I am changing to 1, you execute, see, it doesn't look like a bar. That's why we are changing it to leave a space in between. You can have any values between 0 to 1. 1 represents 1 unit of representation. Okay, so before that, what I did is I'll just show you the data set first. This is a diabetic data set collected from UCI repository, a open source platform for collecting the data sets. It shows how many number of people are there when the pregnancy, glucose level, blood pressure, and so many parameters that they have given, and the outcome is the output. Okay. Now, what I did is I just have used pd.readcsv to read in the data onto the file. Then I grouped the data using the insulin value, and I found how many number of pregnant people are there who is taking insulin. Okay. So what I just did is insulin value, how many people were there, just we have grouped based on the value of insulin the people is taking, and when 94 is the value, let's say how many pregnant people have taken the insulin with 94 as the value. Okay, so that's what I have done using this group by. And if the data, if we want to store it back onto a csv file, we can store it back. So df1.2 csv, what is 2 csv? It is for storing back the results whatever we have computed back to that. And I just have printed in order to understand whether it was the two rows alone we have printed to make understand whether the data is processed correctly. You can see from the sliced diabetes file, again I have drawn a bar chart. Okay, let me execute and show you. 186 different type of insulin, that's why the value becomes too low. So what I did is the maximum value lies for zero insulin, persons who is not taking the insulin. So I'll just, since I have rerun the code, the value came. So I'll just delete, save the file, and then go execute it again. If the 0 goes out, automatically you can see the bar value. Okay. So bar width you can reduce. And you can see the values of this kind. Since the number of values on the x-axis is more, you are getting a very thin bars. Okay. And again one more bar chart is what we have drawn with the two values parallelly. This IPython notebook I'll upload as usual. You can check. Okay. Then comes the pie chart. Okay. This is very interesting. I'll show the output first, and then you can see. I was thinking of the COVID status, and I have drawn this pie chart. The major deaths is in America, followed by UK, followed by Italy, Spain, and then China. That's what I understood. So this list 1 has the set of names of all the countries. List 2 is having how much proportion out of 100. So altogether, if you sum up all these values, it should come to 100 because entire circle is represented as a 100 percentage. Then this explode will tell you how much you want to move that particular sector out of the context. Let's say if I remove this explode, you see I am giving all zeros, it will appear as a circle. This is not looking appealing, right? So I want the America to be projected, okay, in a slightly different way. So I want that particular portion alone has to be moved outside and shown. So if I give 0.1, you can see it was moved out. Okay. So if you want to show some more with some more impact, you can give 0.2. Likewise, you can give the exploding value to whatever you want. Okay. So that is what pie charts refer to. Using this pie chart, I have drawn this concept. See, already we have seen a diagram in the first lecture itself for AI versus ML versus DL. Actually, I tried to draw a similar graph. Just see how it looks like. See, it's a concentric circle. I have drawn by using just a circle concept. You can see here. First I have drawn a pie chart. This blue color states pie chart. Then I have drawn a white circle inside that. Then I have drawn a red circle within that to create 3 concentric circles. AX1, the axis 1 dot pie chart. First we have drawn. I have made only one partition with 100 percentage. So the title I have given is AI versus ML versus DL. You can see it got displayed and the 100% gets displayed over there. And we have created a center circle with 0.70. See, it starts with the center portion of the pie chart or of the entire graph, and it will go till 70% of the complete area. Again, the inner circle is what we have created with 30% of this in red color. Okay, so when you run execute, this is the output. See, it looks very pleasing. You can do anything with the graphs. Histograms represents how many number of values are being present from a particular interval. So what I did, I have created a random list of size 50 ranging from 1 to 20. All the values will range from 1 to 20. The number of items that I have created is 50. The number of bins I have created is 5. So what happens? The values from 1 to 10 will be stored on the first bin, likewise it goes. Okay, and I am drawing a histogram passing this x and the number of bins as the value. Okay, you can see these are some of the outputs that I just have printed. You can see a histogram gets printed. Okay, 5 bins. Well, coming to 3D plotting. Okay, so the most powerful concept. For that, yeah, the Access 3D has to be imported from mpare_toolkits. Now, instead of 2 axes, we are going to have 3 axes, X, Y, and then Z. Okay, so randomly we have created, and in all kinds of graphs that we are doing with 2D can be projected onto 3D also. The only difference is the projection has to be 3D instead of a 2D. Okay, just if you execute, rest of all things are same. It's very similar to a 2D, only with the inclusion of one more axis, which is the Z axis. Okay, see how beautifully it was created. So we have X label, Y label, and then Z label with the 3 different values and how it is created. Coming to subplot, the most important plot having multiple graphs in the same graph. First we'll execute and have a look at the output and then we'll come back. See, it is the different kind of graphs is being displayed like a matrix. Now whatever is there here shows your row 1 and this is your row 2. Okay, so this represents axis 1, axis 2, axis 3, axis 4, axis 5, and then axis 6. So row 1 will be represented. So that is the subplot takes 3 parameters: the row number, columns, number of columns, and then the column number. So now, or the plot number, we should say. Row number is 1, column number is 3 always. Okay, and if you want to place your graph over here, it should be 1, 3, 1. Okay, so in first row, having divide the first row into 3 columns, place your graph on the first column. That's it. Okay, now let us go and see how we have added these things. These are all very simple, and as usual, like the lists are created. Okay, and then we have added the title. See, 6 different graphs we need to add. So in order to emphasize on the fact that some of the subplots can be left empty, I have commented one more axis, that is AX2, right? Figure that is AX1 is equal to add subplot of what is given 131. 131 means first row having 3 different columns. You have to add the graph to the first element. So suppose if it is 133, divide the first row into 3 different columns and add the graph to the third column. Likewise, you have to draw. Okay, any kind of graph can be placed on the any subplot area. Just if you execute, you will get a graph of this kind. Here, this is also one kind of subplot. I'll just execute. Here we have been drawn two different kinds of bar charts. One is vertical bar, another one is horizontal bar. There is no new innovation. It's available as such using the command called bar h. Are available in Pyplot. It's a more convenient way of visualizing the data set before proceeding with the machine learning algorithms. Okay, so you download any data set from UCI repository or from Kaggle, Kaggle, and try plotting the values that you feel is required for you before proceeding to learn machine learning algorithm.